Hi and welcome to my channel. In the next series of videos, we will cover the basic statistical analysis in R. In this short video, we will talk about correlation. So, correlation measures the relationship between two variables. It can either be positive, negative, or zero. In positive correlation, both variables increase and decrease together. And we can see this in this example between sandwich size and the sandwich price. Whenever the sandwich size increases, the price increases too. In negative correlation, one variable increases and the other one decreases. And we can see this between phone thickness and the phone price. Whenever phone thickness decreases, the price increases. In zero correlation, there is no relation between the variables. And we can see this between short size and the short price. Here we have four different sizes: small, medium, large, and X large, and the price always stay the same. The value of correlation ranges between -1 and 1, where 1 is the perfect positive correlation and -1 is the perfect negative correlation. When the value of correlation equals 0, it means there is no linear relationship between two variables, as we can see here. So let's move to correlation tests. So to test correlation between variables, we can either use Pearson test, Spearman test, or Kendall's test. The difference between Pearson test and the other two, Pearson test assumes that your data is normally distributed and only measures the linear correlation. But in Spearman and Kendall's test, they don't assume that your data is normally distributed and they measure the non-linear correlation. So here's just a quick comparison between Pearson's test and Spearman's test. So in Pearson test, it's a parametric test, which means that it only applies if the data is normally distributed, and it measures the linear correlation between the variables, and only applies for continuous variables. Also, when there is a proportional change, like our example in the sandwich, the price of the sandwich and the size of the sandwich. In Spearman test, it's non-parametric test, so it doesn't assume that your data is normally distributed, and it can measure the non-linear relationship between the variables. It can apply for continuous and ordinal variables, and also it applies when the change is not at constant rate. So let's move to how to measure correlation in R. We can use the correlation function to measure the correlation between two or more variables. So here in our example, we have two variables, x and y, with certain values, and we want to measure the correlation. Simply, you can use the correlation function, write x, comma, y, and R will calculate the correlation between two variables, and it gives you values between -1 and 1, as we discussed earlier. So correlation function performs the Pearson test by default. So if you want to specify Spearman test or Kendall test, you need to write it in your command. So inside the correlation function, you specify by writing method equal Spearman or method equal Kendall. So if you want to measure the correlation between two or more variables at the same time, for example, if you have a table which has more than two variables, what you can do is you can write the table name inside the correlation function, and R will measure the correlation between all the variables inside the table. So what R will do, it will measure the correlation between X and itself first, and always it will be 1. Then it will measure the correlation between X and Y, Y and Z, and so on. So if we come to RStudio, so first what we will do is we will retrieve this data frame from R. Iris is a table stored in R, so we can retrieve it, load it to R so we can use it. and we are assigning it to data. And if we press here, we can view the table. You can see first we need to delete this column because it doesn't have a numeric values. So we will access the fifth column, which called species, and assign it to null. And if we go back, now it's deleted. Then what we will do is we will plot the Sepal.Length versus the Sepal.Width. And you can see here there is no linear correlation, but still let's measure the correlation using the correlation function in R. And we can see here there's almost none. It's minus 0.1, so it's close to 0. So if we want to specify the method to spearman, because by default it's Pearson, so let's run it, and we can see a little bit different, but it's nothing significant. So next, what we want to do is we want to measure the correlation between all the variables in the table. So we will use the same correlation function, and we will write our table name, which is data, and we can see the correlation between all of them. And as I mentioned, between the Sepal.Length and the Sepal.Length is always 1, between Sepal.Width and Sepal.Width is always 1, and so on. So we can see here there is no correlation here, but there is a correlation between the Sepal.Length and petal length and width together. And you can also see there is a correlation between the petal width and petal length, and so on. So let's move to our last point in this video, how to measure correlation between two or more variables and get the p-value. Correlation test function performs statistical test and gives you the p-value, but only between two pairs of variables. For example, it can measure the correlation between x and y and return to you the p-value, but it can't apply to the table. For more than two variables, the matrix of correlation function can be used. It calculates the correlation between the variables and also return to you the p-value. To be able to use the matrix of correlation function, we need to install and load HEMSIC package into R. So if we go to RStudio, first let's use the correlation test function to measure the correlation between sepal lengths and petal lengths and get the p-value. So if we run the command, we can see here this is the correlation, and the p-value is way less than 0.05, which is significant. So if we want to measure the p-value for all the table, first we need to install the HEMSIC package, which I already have, so you can do it, and then we will load it to R. Then what we will do is we will use this function, so we'll use it as a matrix, and you put the name of your table here. So we will assign it to data1. And now we want to access the p-values, so we can run the command. As you can see, here is the p-value for each one. And here is the significant one, which is way less than 0.05. And here also we can access the correlation between each variables. So that's it for correlation. Next video will be about t-test, and we will learn how to use t-test in R. Thank you for watching.